Hello, everyone, and welcome back. So, today we are exploring one of the most fascinating topics in artificial intelligence, which is neural networks. So, neural networks are the backbones of many cutting edge technologies, from image recognition to natural language processing, right? So, grab your notebooks and let's get started. All right, so let's start from the basics, okay? Introduction to neural networks. When you say neural network, it's a computational model that is inspired by the structure and function of the human brain, right? So it tries to mimic the behavior of the human brain, and it consists of interconnected nodes called neurons, okay? And these neurons are organized into layers. So as you can see, we have 8 neurons, right? And these neurons are connected by a weight, okay? So this weight shows the strength of the connection between the neurons, okay? And they are organized into layers. So we have the first layer, we have the second layer, and we have the third layer, right? The first layer is the input layer, and then the second layer is the hidden layer, and then the last one, which is the third layer, is the output layer. Now take note, whatever layer that comes between the input layer and then the output layer is termed as the hidden layer. Okay. And if when we have just a single hidden layer, it's termed as a simple or shallow neural network. When we have multiple hidden layers, then it becomes a deep neural network. So now let's move on to how it works. All right, so during learning or training process, this is how it works. It tries to adjust the width, okay, between the connections. So we have neuron A, neuron B. It tries to adjust the width, okay? And it does that by comparing the output to the actual output, okay? So let's say we pass in a value here, and then we are expecting the output to be, let's say 1 and then 2, right? But when the output came, it was, let's say 3, and then here was 9, okay? So it tries to now find the gradient of the loss function, okay, and then try and then update the weight with a technique called back propagation. All right, so that is how it works. It takes in input, compute the input, and then pass it to the next node. The next node does the same thing, and then pass it to the next node, okay. And at the end of it, it compares the predicted output with the actual output, and if there are differences, it tries to now use the technique, as I mentioned, the back propagation to update the weight, okay. And we also have a bias, so it update the bias as well, okay. And as you can see, the previous node, for each previous node, is connected to all the next nodes, right? Now I would like us to move on to the types of neural networks we have. And the first one I would like us to talk about is the feed forward neural network, okay. So it's one of the, or is the simplest neural network, and is formed by, or is when the information is flowing, or is the information flows in just one direction, okay. So when you apply inputs, this input layer computes the input and then pass it onto the hidden layer. It does the same it does the computation and then pass it onto the output layer, okay. So it's just the information just flows in one direction, and that's the feed forward uh, neural network. Now let's talk about the recurrent neural network. With a recurrent network, it has a loop in it. Okay. So as you can see, the output is being applied as an input again to that same node. So when you take this node, its output is fed. So it creates some kind of past or memory. Okay. So it knows its past event. It knows the previous outputs. And in addition to the current inputs that are being applied, it kind of creates some memory for every node. Okay. So as you can see, we have nodes. And when you see, look at the feed forward, we don't have any loop, right? The information flows in one direction. But for recurrent neural network, it flows in, it has a loop. It doesn't flow just in one direction. It has a loop, and it works for sequential data and such as text and then time series. Okay, and then the next one I will talk about is the convolution neural network. So this particular neural network is well suitable for tasks that involves images. Okay, so it uses the convolutional layer that automatically learn historical representation of the features. So let's say when you have an image as an input, what it does is it takes the pixels, okay? So it takes some dimensions of the pixels and then multiply it by a convolutional kernel, okay? And then the output is being stored. So let's come down here, okay? So we have an image, okay? And we will take the dimension of the image, so the pixel. Then we multiply it by this is our kernel, our convolutional kernel. We multiply this by the convolutional kernel, okay, and then the output is being stored here. Then we move on to the next, so it will now be from from here, and then it comes down here, okay. So it will multiply that too with the convolutional kernel and store it here. So it will perform the same thing. When it gets here, it moves down here. And then instead of starting from the first one, it will now start here. So it will be a 3 by 3, right? And then the output will be here. So once it's done with that, it now performs pooling, okay? And pooling is basically undersampling. So let's say after we've gotten our output, we can now undersample this. This for now currently is 3 by 3, right? So we can now undersample it to, let's say, 2 by 2, okay? So when you look at the neural network architecture, we have after the input layer, we have convolution, we have pooling, which is undersampling, then convolution. And so you can, once you are done with the pooling, you can also perform another convolution and then pull it again, perform convolution. So it alternates, okay? And once you get to the final end, you have to now flatten it, okay, to turn it into a 1D array, or yeah, so that you can feed it into whether you're a deep neural network or a shallow neural network to give you the prediction. Okay. So once you are done with the convolution or you are done with the pooling, you have to flatten it to get a straight, or let's say a 1D array. Okay. And then you have to now have a different architecture here, which is either a deep neural network or a shallow neural network, to now do your classification or regression problem for you. Okay. And that is it for convolution neural network. And then the next one we will talk about is the self-organizing neural network, okay, which is known as the self-organizing map. So this is also one of the architectures and is for unsupervised learning, okay. And they produce low dimensional representation of the input space, okay. So this is how it basically works. When these are the neurons, right? And when an input is being applied, the neurons fight for the input. So the neuron that has or share same features or most features with the input layer wins the input. Okay. So let's say X1 is being applied. They will all be fighting. So let's say this neuron, their features are they have common features. Okay. So they have common features. Let's say 80%. So in that case, this neuron wins input one, right? Or X1. And that's in that case, this input will be drawn towards this neuron. Okay. Even though as you can see, these ones are red, right? These ones to share some features with the input, but it's not as much as the winning neuron. Okay. So they will also the input kind of drag towards them as well, but it gets closer to the winner neuron more than any of them. So as you can see, this one also shares some in that order. So let's say X2 also comes in, and then this time around, this neuron wins it. So it will pull the inputs or closer to it, right? And then another one comes, let's say this neuron won it, and then it will pull it closer to it. So it's kind of by the end of the day, you realize it's kind of group the inputs, okay? And we have something like this. So as you can see, once the input comes, they are being drawn, and as you can see now, it forms cluster of, let's say, cluster A, group B, and then group C. Okay, so that is how self-organizing does, and it's unsupervised because we don't apply any or we don't have any outputs, right? We just apply the input, and then the neurons fight for it, and at the end of the day, we can determine or decide to name this as group A, group B, or group C. Okay, so as I mentioned, unsupervised learning. Let's talk about supervised learning and unsupervised learning. So, as we discussed earlier in some of our previous videos, supervised learning basically means you have a marking scheme. Okay, so the model is being given the expected output or the actual output. Okay, so during learning or during training, it tries to predict and then compare its prediction with the actual output, and then if there are differences, it can go back and then update the weight using the back propagation, as we explained earlier on here. Okay, so that is for supervised learning. It has a marking scheme, or it has a label, right? Or it has a dependent variable that after doing prediction, it compares it with it. So it has some kind of marking scheme or guidance. Okay. And some of the examples are the image classification, which we use convolution neural network. And we can use that to classify images into categories such as we should determine whether an image contains a cat, a dog, or anything, right? And we also have speech recognition, which that one we use recurrent neural network. Okay. And it can be trained to transpose spoken words into text. Okay, and it enable applications like virtual assistants and then voice control devices. Okay, and then unsupervised learning, so it's basically the opposite of supervised learning. With this one, we don't have any label, okay, attached to you. We just give you the input. So you have to look at the input and then find some features. So you group these inputs into the algorithm tries to group these inputs based on some features they share in common. Okay. So with this one, the inputs that will be here share most their features are features they share in common are most, right, and then in that order. So it kind of group them without it's them with they don't the algorithm don't have any idea about, let's say, the name of this group, the name of group. What it does is it just try to find the inputs that share most features in common and group them. Okay, so and with that one too, we have some examples like the anomaly detection. Okay, and that is trained to detect unusual patterns and outliers in data. Okay, and we have the and a different example is the dimensionality reduction. Okay, so this technique is like autoencoders, and learn they can learn compact representations of high dimensional data. Okay, so they are using visualization and then feature extraction. So with, let's say, feature extractions, you want to uh, get the most important features in your data set. You can apply the whole data set, and then it will look at them and then find out the features that are most informative, that could help your model to learn well, and then you can use those features for your uh, training, okay, or through your data preprocessing. So uh, that is it for supervised and unsupervised. And we've already mentioned the applications, right? Let's say image recognition using convolution neural network. It has the power for image recognition systems, and they are using self-driving cars, right? Medical diagnosis machines and all those stuff. And we have natural language processing, which recurrent neural network is behind that. Okay, and they are using translation services, chatbots, and other systems. Okay, we also have the finance aspect where neural networks are used to they are used for stock market predictions. Okay, and algorithmic trade. Okay, so that is it for this video. I hope now you have a fair idea about what convolutional neural network is and some of the types and the application areas, right? If you did enjoy this video, kindly click on the subscribe button, like this video, share with friends, and see you in the next video. In the next video, you are going to take these, or you are going to implement these types of neural networks one after the other, right? So see you in the next video.